Good day. I welcome you at the lecture on quality of water. Another subject, environmental engineering, and the related subject code is CE701 and the module number is 3. Myself, Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management, JIS Group. Our lecture on the quality of water will be divided into two parts. In this first part, we will be covering these topics, that is quality of water, the idea on water quality parameters, and the details of physical parameters and the chemical parameters which are required for assessing the quality of water. That means we are talking about the drinking water. Now let us proceed to the lecture. Let us first have some idea on the importance of water. Water is essential to sustain life and is satisfactory, that means adequate, safe and accessible supply must be available to all. Improving access to safe drinking water can result in tangible benefits to health. Every effort should be made to achieve drinking water that is as safe as practicable. Safe drinking water, as defined by the guidelines, does not represent any significant risk to health over a lifetime of consumption, including different sensitivities that may occur between life stages. Those at greatest risk of waterborne disease are infants and young children, people who are debilitated, and the elderly, especially when living under unsanitary conditions. Those who are generally at risk of waterborne illness may need to take additional steps to protect themselves against exposure to waterborne pathogens, such as boiling their drinking water. Safe drinking water is required for all usual domestic purposes, including drinking, food preparation, and personal hygiene. The guidelines are applicable to packaged water and ice intended for human consumption. The World Health Organization considers access to safe drinking water a basic human right. About 1 to 2 billion people lack safe drinking water, a problem that causes 30,000 deaths each week. More people die from unsafe water than from water, as stated by General Ban Ki-moon, the UN Secretary General, in 2010. Drinking water, also known as the potable water, is water that is safe to drink or to use for food preparation. The amount of drinking water required to maintain good health varies and depends on physical activity level, age, health-related issues, and environmental conditions. Americans on average drink 1 liter of water per day and 95% drink less than 3 liters per day. For those who work in a hot climate, up to 16 liters a day may be required. Typically, in developed countries, tap water meets drinking water quality standards, even though only a small proportion is actually consumed or used in food preparation. Other typical uses include washing, toilets, and irrigation. Grey water may also be used for toilets or irrigation. Its use for irrigation, however, may be associated with risks. Water may also be unacceptable due to levels of toxins or suspended solids. So, you can see that there are certain number of general parameters which are responsible for safe drinking water. In our study, we will try to have some knowledge on those parameters, which are as follows. That is, the properties are physical, chemical, and biological properties. Actually, water quality parameters are broadly classified into these three categories. Under the physical parameters, the following properties come, that is color, odor, turbidity, temperature, and conductivity. Under the chemical parameters, the, these are the following parameters that comes as follows, that is pH, acidity, alkalinity, hardness, solid harmful chemicals, chlorides, sulfates, iron, nitrates, heavy metals, pesticides. And in case of the biological parameters, dissolved oxygen, biochemical oxygen demand, and chemical oxygen demand, which are biological parameters that are taken into consideration for the assessment of water quality. Temperature of water is one of the most important physical parameters for assessing the quality of water. In general, it is measured using the thermometers, and it ranges between 0 to 100 degrees Celsius. The atmospheric condition generally influences the temperature of surface water, whereas for the case of groundwater, its temperature is controlled generally by the thermal characteristics of the bedrocks and the depth. According to the American College of Sports Medicine, water and other drinks should be between 50 and 72 degrees of Fahrenheit for optimal hydration. Water temperature is critical because it is an important quality in environmental parameters. It is important to measure water temperature. By doing so, we can see the characteristics of the water, such as the chemical, biological, and physical properties of the water, as well as the possible health effects. Water temperature is an important factor in determining whether a body of water is acceptable for human consumption and use or not. So, the importance of temperature of water are as follows. That is, the temperature in water governs the kinds and types of aquatic life that live in it. It regulates the maximum dissolved oxygen, that is DO concentration of the water. As we can see that temperature influences the rate of chemical and biological reactions. In detail, we can say that the rate of chemical reactions generally increases at high temperature. Warm water holds less dissolved oxygen than cool water and may not contain enough dissolved oxygen for the survival of different species of aquatic life. Hence, it affects the dissolved oxygen level in water, photosynthesis of aquatic plants, metabolic rates of aquatic organisms, and the sensitivity of these organisms to pollution, parasites, and disease. Color of water has great importance for assessing the physical quality of water. Color of water is due to the suspended particles and organic matter that are present within the water. The scale for alpha color goes from 0 to 500 in units of parts per million of platinum cobalt to water. 0 on this scale represents distilled water, or what we generally know as white water. Alpha means American Public Health Association, and these standards can be used for both visual comparison and instrumental measurements. Generally, the color of water ranges from light to dark brown. The brownish color in water comes due to the presence of iron in water. The greenish color in pond is seen due to the presence of organic substances, including algae. While water does reflect blue-green light noticeable in great depths, it should appear colorless as used in the home. Ideally, water from the tap is not blue or blue-green. If such is the case, then there are certain foreign substances are present in the water. While relatively small quantities of water appear to be colorless. Pure water has a slight blue color that becomes a deeper blue as the thickness of the observed sample increases. Basically, the blue hue of water is an intrinsic property and is caused by the selective absorption and scattering of white light. Turbidity is another important physical parameter for assessing the quality of water. Basically, it represents the mudiness in water. It is caused due to the presence of suspended particles which comes from clay, silt or organic matter that are present within the water body. Basically, the turbidity is the property which controls or represents the transparency of water. Transparency is measured using Secchi disk. This is created in 1865 by Angelo Secchi. This is a plain white circular disc of 30 cm in diameter, which is used to measure water transparency or turbidity in bodies of water. The best way to measure turbidity in a wide variety of samples is with a nephelometer, which is also known as turbidity meter. Turbidity meter utilizes a light and photodetector to measure light scatter and read out in units of turbidity, such as nephelometric turbidity units, that is NTU, or Formazine turbidity units, that is FTU. Electrical conductivity is another important parameter for determining the quality of water. Electrical conductivity is the property of a substance to conduct an electrical current through it. The unit of measurement of electrical conductivity is millimeter Hos per centimeter at standard temperatures, which ranges from 100 to 1 lakh. Electrical conductivity is also measured in microsiemens per centimeter. Pure distilled and deionized water has a conductivity of 0.05 microsiemens per centimeter, whereas seawater has a conductivity of 50 millisiemens per centimeter and drinking water has a conductivity of 200 to 800 microsiemens per centimeter. So you can see that the electrical conductivity of saline water, that is the seawater, is quite high with comparison to pure water or the drinking water. The presence of charged ionic species makes water conductive. These conductive ions come from dissolved salts and inorganic materials such as alkalis, chlorides, sulfides, and carbonate compounds. We know that seawater contains high percentages of dissolved salts and inorganic materials. Therefore, the conductivity of seawater is high with comparison to normal drinking water. The electrical conductivity is measured using electrical conductivity meters, and it is directly related to the temperature of water. The higher the temperature of water, the higher the electrical conductivity would be. The electrical conductivity of water increases by 2 to 3% for an increase of 1 degree Celsius of water temperature. As we have already mentioned that pure distilled and deionized water has a conductivity of 0.05 microsiemens per centimeter and seawater has a conductivity of 50 millisiemens per centimeter and drinking water has a conductivity of 200 to 800 microsiemens per centimeter. That means pure water is less conductive. pH is another important parameter for assessing the water. pH stands for potential hydrogen, with P meaning potential and the H standing for hydrogen. The pH scale is a scale that is used to rank the relative basicity or acidity of the substances to other substances based on the amount of hydrogen ion activity in a substance. That means this refers to the effective concentration of hydrogen ions in water. It ranges from 0 to 14 measured in pH meters. Water is said to be acidic if the pH value is less than 7, or alkaline if the pH value is greater than 7, depending upon the relative concentration of hydrogen ions from the neutral value, which is 7. The normal range for pH in surface water systems is 6.5 to 8.5, and for groundwater systems that is 6 to 8.5. Pure water has a pH of 7 and is considered neutral because it has neither acidic or basic qualities. While the ideal pH level of drinking water should be between 6 to 8.5, the human body maintains pH equilibrium on a constant basis and will not be affected by water consumption. For example, our stomachs have a naturally low pH level of 2, which is beneficial acidity that helps us with food digestion. Drinking natural alkaline water is generally considered safe since it contains natural minerals. However, we should use caution with artificial alkaline water, which likely contains fewer good materials than its high pH would have you believe, and may contain contaminants. High pH causes a bitter taste. Water pipes and water using appliances become encrusted with deposits, and it depresses the effectiveness of the disinfection of chlorine, thereby causing the need for additional chlorine when pH is high. Low pH water will corrode or dissolve metals and other substances. Total dissolved solids, that means TDS, deals with the concentration of non-volatile substances present in colloidal state or in molecular state in water. It represents the total of all ions present in water expressed in ppm, that is parts per million, or in milligram per liter. This is generally increased due to the dissolution of more mineral substances by water on its path. TDS, that means total dissolved solids, determines the suitability of water for our use and consumption. This following table deals with the types of water with respect to the concentration of TDS present in water. If the TDS is less than 1000 ppm, then it is considered as fresh water. While if the TDS between 1000 to 10,000 ppm, then the water is considered as brackish water. Brackish water means the water having more salinity than fresh water, but not as much as seawater. If the TDS is between 10,000 and 1 lakh ppm, then the type of water is considered to be saline. But if the TDS is greater than 1 lakh ppm, then the water is considered to be hypersaline or brine. The dissolved constituents, that is the total dissolved solids, can be classified into three categories. The first one is based on concentration, the second one is based on ionic charges, and the third one is based on toxicity. The classification based on concentration can further be classified into three categories. One is major ions, one is minor ions, and the third one is trace elements. Generally, the major ions, that means the concentration of major ions, is more than 10 mg per liter in water. And those are mostly bicarbonates, calcium, magnesium, chloride, sodium, sulfate, and silicon. In case of minor ions, the concentration is in between 0.1 to 10 mg per liter. And those are mostly carbonate, fluoride, nitrate, potassium, iron, strontium, boron. And for the trace elements, their concentration is less than 0.1 mg per liter. And those are mostly aluminium, arsenic, barium, bromide, cadmium, chromium, cobalt, copper, lead, zinc, nickel, phosphate, silver, tin, vanadium. So you can see that from major ion to trace elements, the concentration is getting lower. Here, one point should be reminded for the trace elements, that is, trace elements play an important role in the use of water. Some are essential for health and growth. Some are injurious to health and toxic also. Here I am talking about lead, then arsenic. These are very injurious to health. Deficiency or excess intake of some trace elements may cause serious problems to life. Now comes the total solids based on the ionic charges. They are further categorized into two parts, that is, one is cations and one is anions. Cations are normally positively charged and anions are negatively charged. Cations, the list of the cations dissolved constituents are calcium, magnesium, sodium, potassium. And for the anions, the major anions are bicarbonate, carbonate, chloride, sulfate, nitrate, phosphate. And in terms of level of toxicity, the total dissolved constituents can be categorized into toxic or non-toxic categories. Hardness of water is an important parameter for assessing the quality of water. Hard water is water that has high mineral content. It is formed when water percolates through deposits of limestone, chalk, or gypsum, which are largely made up of calcium and magnesium carbonates, bicarbonates, and sulfates. So, the simple definition of water hardness is the amount of dissolved calcium and magnesium in water. Hard water is high in dissolved minerals, largely calcium and magnesium. So it is expressed as total concentration of calcium and magnesium in ppm. Generally, the harder the water, the lower the toxicity of other metals to aquatic life. In hard water, some of the metal ions form insoluble precipitates and drop out of solution and are not available to be taken in by the organism. Large amounts of hardness are undesirable, mostly for economic or aesthetic reasons. Hard water is not a health hazard. In fact, the National Research Council states that hard drinking water generally contributes a small amount towards total calcium and magnesium human dietary needs. They further state that in some instances where dissolved calcium and magnesium are high, water could be a major contributor of calcium and magnesium to the diet. Total hardness is calculated as 2.5 of calcium plus 4.1 magnesium. So the two main cations that cause water hardness are calcium and magnesium. Calcium is dissolved in water as it passes over and through limestone deposits. Magnesium is dissolved as water passes over and through dolomite and other magnesium bearing formations. Here one point to be remembered, that how can we remove hardness of water if needed. Permanent hardness present in the water can be removed by treating it with soda water and using permuted process. Soluble salts of calcium and magnesium change into insoluble salts due to the treatment with sodium carbonate. That is the washing soda, or we call it a sodium soaps. Salinity of water is one of the major important parameters for conducting the assessment of quality of water. By definition, we can say that salinity is the measure of the amount of dissolved salts present in water. The deionized water by its nature has very few ions, whereas seawater has a relatively large number of sodium and chloride ions, and it has a conductivity of around 5 Siemens per meter. This is because the sodium chloride salt dissociates into ions. Hence, seawater is about a million times more conductive than fresh water. So we can say that saline water conducts electricity more readily than fresh water. So electrical conductivity is routinely used to measure salinity of water. As salinity increases, it may become toxic to native freshwater organisms. Not only this, but salinity also can decrease the plant growth and water quality, resulting in lower crop yields and degraded stock water supplies. Excess salt affects overall soil health, reducing productivity. It kills plants, leaving bare soil that is prone to erosion. The major ions in seawater present are chloride, sodium, magnesium, sulfate, calcium, potassium, bicarbonate, and bromine. Many of these ions are also present in freshwater sources, but in much smaller amounts. While freshwater usually has a higher bicarbonate ratio, seawater has greater sodium and chloride concentrations. Normally, seawater contains 35,000 ppm or milligram per liter of dissolved salts, whereas in freshwater, the concentration of salts or salinity is nearly zero. Here, one point which is to be remembered, that while there is no drinking water standard for sodium, various state and federal agencies recommend sodium levels in water should not exceed 20 mg per liter for those people who are on very low sodium diets and 270 mg per liter for those people who are on moderately restricted sodium diets. Most of the salt we consume generally comes from the regular food we consume. Alkalinity of water is one of the major important parameters for assessing the quality of water. By definition, we can say that alkalinity is the combined effect of bicarbonates and carbonates with calcium ions present in water. Alkalinity is the measure of the buffering capacity of water, or the capacity of water to neutralize acids and resist the pH change. The presence of calcium carbonate or other compounds such as magnesium carbonate contribute carbonate ions to the buffering system. Alkalinity is often related to the hardness because the main source of alkalinity is usually from the carbonate rocks, which are mostly CaCO3. Carbonates will be noticeable in water for having a pH of more than 8.2. The amount of alkalinity that should be in our water is 20 to 200 mg per liter for typical drinking water. Whereas the desirable range for irrigation water is often taken as in between 0 to 100 ppm of calcium carbonate. Alkalinity is basically dissolved minerals in the water that help neutralize the water we drink. Water can be high or low in pH, but if it is too high or too low, it can have adverse effects. Water that is too alkaline has a bitter taste. It can cause deposits that encrust pipes and appliances. Highly acidic water may corrode metals or even dissolve. So, in this lecture, we have gone through various physical and chemical parameters which are very important for the assessment of quality of water. As a thorough assessment of all these parameters are very important. Thank you.